Alright, so we've covered factoring in three different ways. One was the GCF method, which is always our first go-to form for factoring. If you see a GCF, you should factor it when asked to factor. After that, we learned two other methods, which are dependent on the situation: trinomial factoring and difference of squares, D of S, difference of squares. So let's take a look at this one. We were asked to factor completely, so we need to factor and factor and factor until we can factor no more. And this happens a lot more when your a value of your polynomial is not equal to 1. So when it starts with some value that is not equal to 1. In this case, it is a GCF of 3x. So by factoring that out, we're left with x squared plus 15x plus 50? Yeah, 50. Now, looking at this, this looks like something that can be factored. It's a trinomial. So we have to think, how would I factor this? And memory serves, we have to look for the factors of 50 that add up to be 15. So 1 and 50 doesn't work. 2 and 25 doesn't work. So these aren't good. 3 doesn't work at all. 4, nope. 5 and 10. Let me write that a little more clearly. 5 and 10 does work. Does add up to 15. So we don't even need to check the other factors, the negative ones, negative 5 and negative 10. So we already found our possibility. So this becomes 3x, x plus 5, and x plus 10. Now, if either of these things could be factored, we would factor it further. If this could be factored, we'd factor it further. But in this case, nothing here can continually factor. So this is 3x to the third plus 45x squared plus 150x factored completely. Let's look at another example. We were asked to factor this completely. So we always start off by thinking, what is the GCF, if there is a GCF? In this case, both of these terms are divisible by 5. So we can factor out a 5, and that'll leave us with x to the fourth minus 1. Now, x to the fourth minus 1 looks like something we can factor. It appears to be a difference of squares. So let's factor that. So we'll get 5 x squared minus 1 x squared plus 1. Because the square root of x to the fourth is x squared, and the square root of 1 is 1. And it's plus and minus the square roots in this case. Looking at this, this can still be factored. This is also a difference of squares. X squared minus 1 also can be factored. So we'll factor that as well. So that's x minus 1, x plus 1. And we have x squared plus 1. Now, 5 can't be factored. X minus 1 can't be factored. X plus 1 can't be factored. And as we discussed in a prior video, the sum of squares cannot be factored. So this has been factored completely. Alright. So that's where we would stop. Again, you look for GCFs more often when your value of a is not equal to 1. Let's look at one more example. 15x squared minus 2x minus 8. Factor completely. We're going to use a new technique. It's called grouping. We'll see why we need to use it. It's one of the more confusing techniques and it's harder to explain, but we'll take a look at it. I assure you this can be factored. I know it can be factored because I started with its factors and multiplied them out to get this product. And if I could obtain it by multiplying, I should be able to factor it. What is the GCF? Does it have a GCF? 15, 2, and 8 have no common factors. The factors of 15 are 5 and 3, which don't go into 2, or 8. The factors of 2 do go into 8, but don't go into 15. And same thing goes for 8. 8 and 2 share a factor, but that's it. So how do we do this? Well, it's kind of a tricky method. We actually start off by... Here, we'll have to write down a set of rules that'll help. multiply a and c. This only works for trinomials where a is not equal to 1 but has no GCF. So we're going to multiply a and c, and that is 15 times negative 8, which is the same thing as saying negative 120. Okay, so that's our AC term. What on earth do we do with that? We're going to split that into two terms. We're going to split our center term into two terms. So let's write that down as a rule. Split B term into two terms that multiply to be AC. So what are two values that multiply to be AC in this case? I think negative 12 and 10. Alright, so this becomes 15x squared minus 12x plus 10x minus 8. Alright, and there are a billion ways we can break this down. There are infinitely many ways we can find two numbers that add up to be negative 2. But this is the only one that multiplies to be negative 120. And then the question comes, why do we do that? Oh, actually, the order of these values is also important, and I put them in the wrong order. They should be written in the order which appears to have common factors. 15 and 12 have a common factor, but 15 and 10 also have a common factor. 10 and 8 have, does it matter? In this case it might not matter actually. But the order sometimes will change how easy it is to factor. What is the common factor of these two terms? This is why it's called grouping. We're going to group pairs of terms. Alright, so there has to be an even number of terms, and that's why we needed to split this up. Because this is a trinomial, it has 3 terms. But normally, a trinomial comes from 4 terms, and the two like terms get combined. Alright, so grouping these, what is their GCF? The largest number that can be divided out of both of these is 3, and we can also take out an x. So this will become 3x, and what's left over here is 5x minus 4. Okay. The GCF of these two terms is just 2. So if we factor out a positive 2, let's do that in blue, a positive 2, the remainder here will be 5x minus 4. Now you should notice something. These two terms, these grouped terms, have a common factor, a greatest common factor. Its greatest common factor is 5x minus 4. So we can actually separate that out, 5x minus 4, and when we divide this out of these, it only leaves over the remaining two terms, the 3x plus 2. Alright, so I guess the third step, which I didn't, it's harder to explain, it's easier to work out, is to group terms. Okay, that's what happened here. Group these two terms, Alright. Factored out the GCF, and factor out their GCFs. And then it's kind of a repeat step. We factor out polynomial GCF, which is what we did here. We had a polynomial GCF here. The GCF in this case was 5x minus 4, which is not a single term. Alright, well, you'll experiment more with these in class, but they are kind of tricky.